Hey, g'day, it's Presto and thanks for stopping by. Now this is episode 7 of building a pair of replica vintage Cleveland racer toy cars. Now I have an original which is over 100 years old and I wanted to make 2 replicas, and there is a playlist for this series and the link is up above there now if you missed any of the previous episodes. But in the last episode I made a set of these squishy urethane tyres for one of the cars. Now the other car was only ever meant to be used as a display, and it had a set of fairly rigid and hard polyurethane tyres, and I was okay with that, but having 2 sets of tyres, both different, didn't worry me too much, and I thought I was done with that process of making tyres. But then a gentleman named Phil Menzies got in touch with me in the comments and he said, you know what, those tyres turned out great, but they should have some embossed text on the side of the tyre. Now he sent me what he thought should be on the tyre, and it's Avon 6.5-80 B24Z. I checked out the Avon Tyres website. They do actually make vintage or replica tyres for both motorcycles and race cars, and the one that he had nominated looked very similar, although scaled, to the one that's on the Cleveland Racer toy. And I thought about it for a minute and I thought, you know what, hold my beer and watch this. And I thought, you know what, I think I could do that. I think I could make a mould with the embossed text in it and make another set of tyres. So that's what I'm doing. So I've actually got one sitting in the vise here at the moment curing, and I've made 3 others which turned out okay-ish. And although it's not as good as I would have hoped for, it was an interesting exercise just the same. So why don't we look at that first, and then we'll come back and we'll do some more processes to finish off these cars. With this Vitaflex resin you can measure it out by volume, so I've got these little plastic shot glasses and I just fill it up to the second rim or the second line on that plastic container, and that's enough to do 1 tyre. And according to the instructions you put the pigment into part B, which is this creamy coloured liquid here, and this stuff is called So Strong and you only need 2 drops. In fact, if you put in too much pigment, it can affect the curing of the resin. So that's 1, that's 2. And that's sufficient to turn that into a perfectly black mix. So we'll mix the pigment into that part first. So you can see that's gone quite black there now, and it stays that colour. Alright, now this other liquid, this part A, is much thicker, It's more like honey. So I usually mix the part B into the part A. And you sort of want to make sure you get it all. Alright, then you need to mix this really thoroughly. And I recommend you sort of get a flat scraper and go around the edges of the cup. Scrape the bottom. Just make sure you don't leave any areas that haven't been mixed. Now, of course, you've got to be really careful that you don't stir a lot of bubbles into this. Now, I'm going to degas this in a vacuum chamber, but if you were doing this and you didn't have any way of degassing this resin, you'd have to be a bit more careful on what I'm doing here. Alright, so I'm going to go around the edges of the cup now, try and scrape all of that stuff into the centre. And you sort of see how thick that is. And initially I was really worried that I wouldn't be able to inject this into the mould with a syringe. But you can do it, it's just a bit slow. Alright, I'm going to take this in next door and put it in the vacuum chamber. This is my vacuum setup that I'm using to degas this resin. So I built this a number of years ago and I was doing some veneer work and I needed a vacuum bag to pull the veneer down onto the wooden substrate. So it uses compressed air and it goes through a thing called an ejector, and it's operated by a solenoid here, so electrically powered solenoid. And there's an old propane tank underneath here which I'm using as a reservoir for the vacuum. Now, for the vacuum chamber itself, it's just a Pyrex dish with a silicone seal on top, and I've got an acrylic lid that goes on top of that again with the connector for the vacuum hose. So I'll put our resin inside here and I'll connect it all up and I'll show you how that works when it pulls the air out. Alright, so I've got my resin in the Pyrex dish there. Just going to put that silicone seal on top and make sure you get your lid aligned correctly. Alright, turn the air on. And I'm going to open the valve which will create the vacuum in this container. So you can sort of see a lot of fine bubbles on top of the resin now. And I usually leave that in there for about 5 minutes and it just gradually pulls all of those really fine bubbles to the top of the container. And when you release the vacuum, you see the volume of the resin expands just momentarily, and that seems to burst the rest of the bubbles. Now, if everything's really vacuum tight, that air solenoid should actually switch off. But I've probably got a few leaks in this system at the moment and it's still allowing air through the ejector, which is maintaining the vacuum. But in a perfect system, that would just sort of pull the vacuum down and then just switch off. That's been about 5 minutes and there are still some very, very fine bubbles coming to the surface, but in the past that hasn't been a problem. So I'll just switch the air off and turn off the valve for the reservoir. And when I release this, you'll see a change in the surface of the resin. So all those little bubbles just sort of instantly burst. Alright, so I'll go and get this into the mould now. So this is the half of the mould that's got the embossed lettering and numbers inside it. I've already got my screws attached from underneath and we're just going to fill this half of the mould. The only reason I do this is so that I don't have to put so much resin into the syringe. Now also I'm hoping that that resin will just flow into that embossed lettering and completely fill it. Now, to fill the syringe, I've made this little block and it's just got a number of holes in it so I can stand the syringe upright. And we'll pour the rest of the resin in. And I saw in a video that if you do this in a long, thin stream, it helps to get rid of any bubbles that might still be in the resin. Alright, I've just got the syringe started there, and then I'll invert the syringe and allow the air to go to the top and then squeeze that out. And now we can put this together. Okay, I got all this tightened up and in the vise, and then we'll get the syringe sorted and then we can start injecting. This is always the messy bit. There's always a little bit squeezes out. Alright, so now the air is coming to the top of the syringe. You just got to allow time for that to happen. Alright, so I'm going to try and get rid of the air now. So I'm just going to close that syringe. Now the resin's coming out. I'll just let that rest in there while I get things sorted over here. One of the good things about this resin being a lot thicker than the other material I was using, you get more time and also it doesn't run out of the mould. So even though that hole goes right through to the cavity inside the mould there, the resin doesn't want to run out easily. And now all we do is just slowly push that resin in. Okay, it's just coming out the top there now. So you get a better view from here, but what I do is allow some of that resin to come out and sit on top of the mould, just to ensure that any trapped air is coming out. And I'll usually come back about every 5 minutes, just pump a little bit more in, just in case any air bubbles have risen to the top and are still trapped in the cavity. They'll come out and sit on top there. Alright, it's been about 5 minutes, so I'll just give that another squeeze. And that's pretty much pure resin that's coming out of there. Alright, I'll leave that overnight. We'll open it up tomorrow and see what we got. Well, not as detailed as I would have liked, but it is there. So there you go, Phil Menzies. Sort of made it work. Anyway, I'm going to do 4 more of these and they will have the faint outline of some tyre branding and sizing. Next step in making these wheels is to bond the 2 halves of the wheel together, trapping this urethane tyre in between the 2 halves. Now what I've done previously is I cast and machined and powder coated these wheel halves, and there's a piece of brass tubing that fits through the centre of each wheel, and that's sort of a running fit on the steel axle for the car. But what I need to do is to rivet over both ends of that brass tubing on either side of the wheel, and that will trap the tyre in between and make it nice and rigid and tight. Now this one hasn't been processed yet, but it's possible to actually spin the tyre on the wheel if you really try hard, and also being flexible you can sort of prise it away from the wheel rim as well. So I also want to be able to bond the tyre to the aluminium wheel half as well. So I'm going to go through that process now and I'll show you what I've sort of worked out. But the first step is to anneal this piece of brass tubing so that it's soft enough that we can rivet it over. So we'll do that first. I'll just get this up to a nice red heat, quench that in water, and that's now soft enough that we can process that without any worry about cracking the brass tube. I'm going to use some of this black silicone, just roof and gutter sealant, to act as a bonding agent, and if we get a bit of squeeze out here it doesn't really matter, it matches the colour of the tyre. So what I've been doing is just sort of smearing this face of the wheel with the silicone. Like all silicone, it's terrible stuff. You end up with it on your fingers, you smear it everywhere. So you've got to be a bit careful about cleaning up when you're done. So I find that that's enough. Right, all you have to do now is actually put the tyre onto the wheel rim. That extra silicone on the inside there doesn't really matter. That actually helps to bond the two halves of the wheel together. Then we can push our piece of brass tubing through. Now it's sized so that it just protrudes from both sides of the wheel when it's fully pressed together. So it's about 1 millimetre of stick out on both sides, and now I've got a punch and a die to form that over. So this is sort of like a die or an anvil, I guess. And it's just sized to fit the same diameter as the axle in the centre there. And we're going to just clamp that in the vise. Now the punch has two different profiles. This one has sort of a concave profile to it. This will help to flare out the end of the brass tube. The other end is just a square shoulder, and this will finish the forming process to fold that material down flat against the end of the wheel face. So we're going to start with this one here. So we just put the punch through the brass tubing and then into the anvil, and we're just going to tap this down with a hammer. And that's now flared out. We do the same thing on the other side. And you sort of feel when it's completely formed. That one there is now flared out. And then we turn the punch over and use the square shoulder. And that sort of formed that down into a nice sort of like a flattened flare, I guess. Actually, that one's already done. Don't need to do that. So what that does is it actually presses the two halves of the wheel centered together, and it traps the tyre fairly tightly. But also when that silicone starts to set, it sort of bonds the tyre to the wheel center, so there's less chance of it sort of coming off. Alright, so that's it. I'll give this a clean up now where any of that black silicone is squeezed out. I just clean it off with mineral turpentine and that wheel is done, and I'll get the rest done off camera. I let these axles just sit on their copper wire for about 3 days without touching them, and that allows that passivated finish to harden up. And just for reference, this is a commercially made zinc plated nut with the same passivated finish, and I think you'll agree that they look the same. So these axles will last quite well now. They won't corrode easily in the application we're using them in. Now I need to get on and actually put all of these decorative panel lines in the finished replica cars. And I was looking at this really closely the other day, and all of these louver lines in the side of the car body here look slightly different. Now I'm just guessing, but I think that probably in the factory what they would have done is use some sort of a circular saw or an abrasive wheel on a spindle, and the operator would have just moved the casting underneath that abrasive wheel or that saw blade, because all of these endpoints on these louvers are slightly different. They're not particularly straight or evenly cut, so I think I can get away with using some sort of a hand tool to do all of this. So what I'll do is I'll mark this one out and then we'll have a go at doing that process. And what I did here was I got one of these failed castings and I tried out every possible tool that I thought might do the job. So trust me when I say I tried them all. I tried Dremel with an abrasive wheel. I tried rotary burrs. I've tried hand tools, saws, files, all sorts of things. I think I've settled on the tools that might do the job. So I'll get this one marked out and then I'll show you as we start doing that process. One of the reasons I'm using tape here to define the ends of these louvers is that I don't want to scribe a line in the body of the car running along the length of the body, because that scribe line would be visible later and very hard to remove. This way I can mark my divisions on the tape, take the tape off later, and there's no scratch marks left in the material. And before you ask, I did remember to divide the height correctly this time, so I set it from this front axle position, which is the widest one. In a previous video I packed up the bottom of the axle position at the back here, but forgot to add the packer to the top. So yeah, what can I say? I'm old. Pretty much finished all of the filing on these now, and it's almost inevitable, but at some point you will slip with the point of the file and leave a bad gouge mark in the polished aluminium. So there's one here, there's a couple across here, another one over this side that's quite deep, and that means having to sand back quite aggressively to get down below all of those scratches and then come back up through the abrasives until you're ready for polishing. Now I've already done this one here. It's pretty well ready for some very fine abrasive and then the final buffing process. I'll get this one up at the same point and then we'll do the assembly and we can finish up. Well, there's the finished cars, and I must say I'm really happy with the way these have turned out. So both cars now have the rubbery urethane tyres, which is a vast improvement on these rock hard polyurethane tyres that I made. Not sure what I'm going to do with those yet. But I must say that working with that urethane resin has given me a lot of confidence in using that material again. So if ever there's a project that comes up that needs some sort of a flexible rubber-like component, I'll be able to do that, I'm fairly sure. Now I'm really happy with the red powder coat as well. I think that's more in keeping with the original Cleveland racer from what I can find out. And they both now have their lovely zinc plated axles and they won't corrode easily. And a viewer did recommend that I stamp the finish date into the castings just in case someone tries to pass these off as original Cleveland racers at some point in the future, which they're very much not. These are just replicas. So here's the original here, and if you look at these closely side by side, there are some differences, mainly to do with the width of the cockpit. The radiator end is slightly different on the replicas, but that's okay. They were just meant to look like a Cleveland racer and capture that sort of classic vintage toy look. Now, working with these castings has given me an idea to work on another project coming up, which will be similar, but it won't be a car. But that's not the next project. I'm going to give you a very brief preview of what the next project looks like. So what you're looking at there is called the Crusader 60, and if you saw my series on the Titan 60 model aircraft engine by George Ginevro, the Crusader is a similar sized engine, but you can build it completely without casting, so it's all made from bar stock and whatever you may have lying around the workshop. So I'm going to build one, and you can join me and have a look at how that works. So that's coming up soon. But that's all for today. I'll give you a close-up look at some details on the cars and also some wildlife that we saw around the garden in the last couple of days. So thanks again for watching. I'll catch you on the next build series. It's Prezzo signing out for now. Cheers. Friend the wallaby, maybe he's getting more used to us.